The International Space Station is the largest man-made structure in space. In this video, I want to give you a detailed look about how each module is launched and assembled in orbit, about the countries that are participating, and a future plan for the station. If you're ready, let's go build a station. The International Space Station, or ISS, took many years to become a reality. In 1984, the United States announced a project called the Space Station Freedom. Here's some drawing of what the original station might have looked like. It was never actually built its original form. There were lots of redesigns, and its funding was almost completely cut by the US Congress. Then in 1993, after several countries were brought on board, the name was officially changed into the International Space Station. 5 years later, construction begins in space. I'll show you the complete construction progress. But first, let's learn a little bit more about the station. This is the ISS as it looks today. It's mainly used for conduct science experiments that only can be done in space. There's usually 6 astronauts on board the station, and they generally switch out about every 6 months, so that no one spends too much time in space. The International Space Station is about the size of an American football field. It's located just outside the Earth's atmosphere. This is called low Earth orbit. It's not very high up considering some satellite orbit all the way out here. The ISS only takes about 92 minutes to orbit the Earth. That's about 2008, not about 28,000 kilometers per hour. Over time, the ISS will slowly lose its altitude. If nothing was done, the station would eventually burn up as it's re-entering the Earth's atmosphere. So to prevent this, the station must be periodically reboosted to stay in space. The main countries now are participating are United States, Canada, Russia, Japan, and many countries in the European Space Agency. Let's get to know the main part of the station. The integrated truss structures, like the kind of the backbone of the station, is called the solar arrays to generate electricity. The radiator panels, these remove heat from the station and other equipment. And science experiments are also attached. This part down here contains the pressurized module, which means that the astronaut can live and work in there without a spacesuit. Out of the Russian module in the Russian orbital segment. The other side is called the United States orbital segment. It's made up of modules that from the United States, Europe, Japan, and Canada. The different pieces of the station, also called module, were built in many locations around the globe. Each module was then launched into space by one of these 3 rockets: the American Space Shuttle, the Russian Proton rocket, and the Russian Soyuz rocket. Once in space, it's time to put it all together. This is definitely your Alvarin Lego set. Once construction started, the INS looked a little over a decade before considered complete. Each of these lines represent the addition of new module to the station. Let's go ahead and start from the very beginning. The first piece of the station is a Russian module called Zaira. It provides power from the solar rays and also propulsion when there's a need to move the station. There are three docking ports in front and one in back. This will be used to connect it to the next pieces of the station. The second module is American. It is called Unity or Node 1. It has 6 docking ports to connect to the future modules. There's a special piece here to connect between the different docking mechanisms. And this is called the Pressurized Mating Adapter, or PMA for short. Unity was launched with PMA 1 and PMA 2. This is the Zvesta service module. It provides life support systems and is considered the functional center of the Russian orbital segment. It also has 3 docking ports in front and 1 in back. Next is the Z1 truss. It holds equipment for the station. It's not part of the main truss, but it provides a temporary mounting place, as we see here in a moment. PMA 3 was added to the bottom side of Unity. It's always good to have an extra one of them around. The P6 truss was temporarily pressurized to top of the Z1 truss. This includes the first solar rays wing. This provides much needed power to the growing station. Radiator panels were also installed to remove excess heat from the station. At this point, there was enough functionality that astronauts can start living aboard the station instead of just temporary visits. From November 2000 until now, there's been a continuous human presence on board the station. The Destiny module is also called the US Laboratory. This is where a lot of scientific research happens. A little rearranging made so that the Destiny could be installed. March 2001 came the addition of the External Storage Platform 1, or ESP1. This was a place to store spare parts for the station, and Canada made a vital contribution with the Con-Am 2. It is a robotic arm that can help around the outside of the station. It's usually controlled by an astronaut that sits inside the station. Neither end of the arm can be attached to one of these grapple fixtures that you find on various modules. The Quest airlock allows the astronaut to safely step outside for a few hours to perform an EVA, or also known as a spacewalk. This is a Russian module called Pirs. It can be used as an airlock for spacewalks and also a docking port to allow visitors visiting spacecraft to the station. Now we get to start building the integrated structure. If you remember from earlier, this is like the backbone of the station. Our first base is the S0 truss, and it's get attached to the top of the Destiny module. The Mobile Remote Service Base System, or MBS, was added next. This platform can move along the truss. It's especially helpful when the Conodam 2 is attached. Then the S1 truss was added, followed by the P1 truss. The S stands for starboard and P stands for port. This way, you know on which side of the station is on. Each side has room for 3 more radiation panels. For now, only the center one will be installed. ESP2 was added to the station right next to the Quest airlock. This is the P3, P4 truss segment with solar rays and other radiator panel. The tiny P1 truss goes at the end here. To balance out the station, we have to retract the field panels. The following years, the other side of the truss were added as well. ESP3 goes down here. And then the P6 truss can be moved to its final resting place. It's also time to deploy a few more radiator panels. The Harmony module, also called Node 2, it will be attached to the forward end of Destiny module. But first we have to do some rearranging. Harmony has 6 docking ports, which allows the further expansion for the station. Next comes the Columbus module, which is an European space laboratory. Now we get some robotic arms, what's also built by Canada. This is a space robot called Dexter. It can attach to the same grabber fixtures that are used by the Conodam 2. In fact, Dexter is most useful when it's attached to the end of Conodam 2. The largest module in the Japanese experiment module, or also known as Kibo. It came up to the station in several pieces. It even has its own robotic arm. Finally, that we have the S6 truss, the last truss segment. Now we are starting to look a little more like a space station. The solar rays will be rotated that they face toward the sun. This helps the arrays generate more power to the station. The Japanese experiment module has one last addition. It's called the Japanese Exposed Facility. This allowed research to be conducted in the vacuum of space. The Russian module Point is very similar to Pirs. It was another place for Russian spacecraft to dock. This is the first Express Logistics Carrier, or ELC-1. This is a place to store hardware to help the station work correctly. ELC-2 was installed on top of the stuff here. The Tranquility module, also known as Node 3, is added to the side of Unity. On the bottom side of Tranquility is a small room called the Cupola. This has 7 windows from which to see the view. Each window has a cover that can be closed when they're not in use. Then came another Russian module called Rasvet. It could be used to storage and another docking port. The Leonardo module is used for storage of supplies and wastes. The trash will build up here until it can be removed from the station. Here's ELC 3 and 4. This is a science experiment called the Alpha Magnetic Spectrometer. It's used to study the rare particles such as antimatter. A more recent addition to the station is the Bigelow Expandable Activity Module, or BEAM for short. It takes up a small amount of space during lunch and then inflated once attached to the station. BEAM is an experiment to see if this kind of technology can work. The ISS had only funding through 1929, but hopefully that will be extended. After that, we may see pieces of the station repurposed for other projects in space. That's all about my video. Thank you because you support me on this video. Goodbye and see you again.